Now let's solve this problem using dynamic programming 2D grid. And let me take the same example as it was there in the lead code. Word 1 as horse and word 2 as ROS. I changed this word to here ROSE in my previous videos so that it was easier to explain about this algorithm that we were discussing. The algorithm, again, to revise is that if characters match, and then we have to just discard those characters from both the words and then move on to the remaining substring. And if the characters don't match, in that case, we have to take the minimum of, there are three possibilities. We can remove this R character and take the minimum of HO and RO, edit distance, or we can remove O character and find the minimum of HOR and R, or we can delete both the characters R and O and find the minimum of HO and R. So these are the three possibilities, and we have to find the minimum of this. So now let's again create the grid now. So the word 1 here is HORSE. So let me take some space. HORSE, and I'm taking one extra character here. I will explain why. I need to define my base or terminal condition here. Okay, and we are interested in this part. Let me highlight this. And as mentioned, that I need to define a base or terminal condition here just as null. And we will keep on filling these values from here to here. And here it will be giving me the final solution, the minimum edit distance, by the algorithm that we just devised in our previous video. So let's start this now. Let's start filling from here. So null by null means that for this cell, it should be always 0, right? Because null doesn't mean anything. We don't need to have any edit to move from here to here. So it would be 0. Now for between this and this, if I want to edit, it says this is word 1 and this is word 2. Word 1 is only having hash and word 2 is only having R. It means that I need to insert R, that is the minimum edit distance of 1, to convert from word 1 hash, null, to R. So it would be at least like 1 by inserting R into this. Similarly, if I take RO and null, it means that I need to insert two characters, R and O, to transform word 1 phi to this RO. So it should be 2. Similarly, we find this is 3. We need RO as 3 characters to be inserted to convert from this hash to ROS. Now let's go to this terminal condition in column. So here we are comparing this with H. So we need to insert H character, at least H character, to convert from word 1 to word 2. Similarly, for HO, it would be 2 characters inserted. Similarly, it should be 3, 4, and 5. So this is our base condition that we have already discovered, that how many edits are required to convert from here to here. Now let's go to this interesting part, which we are actually dealing with the actual words. Now H and R. We found that here in this previous approach that if H, the character, doesn't match, in that case it would be at least 1 plus minimum of, if I remove R, or if I remove H, or if I just take the previous one. So for example, here the cell which corresponds to this part, but that is one above it, it means that we have removed H from here and we are just dealing with H, hash, and R. It means that we have removed this H character and we are just dealing with the edit distance available, only including R. So this is one possibility. It should be this one, minimum of this, or we can remove the R character and just take H. So it should be 1, this cell, We remove this, and so, or it can be like removing both R and H. This is the third condition. This is the same formula as we decided here, that should be minimum of all this. We just keep on removing from source word 1 or word 2. Word 1 removal is this cell. Word 2 removal is this cell. And if we both remove both characters, it would be this cell. So it should be minimum of this left cell, the left diagonal cell, or the up cell. We found that minimum is 0. It means that 1 plus 0 is 1. Okay. So again, H and O, I mean, we keep on filling it, then it will be further clearing up our understanding. Now again, let's go with H and O. H and O don't match. So either we can remove O and just treat with the R, hash and R and hash of H, which is this cell. After removing O, it can be, so 1 plus minimum of this, or if I remove H, then it would be R, O, and phi, that is 2, minimum is of 2, or if I remove both O and H, then we are removing this cell. So the idea is that we have to find the minimum, 1 plus minimum of the cell left to it, to the left diagonal and to the up. We found that minimum is 1, so which would be 1 plus 1 is equal to 2. Okay, similar formula. We found that minimum is between these 3 cells is 2. So it would be 1 plus 2 is 3. Now again, go with O and R. Let's fill on the remaining cell, and the solution would be here when we exhaust all the characters from both words. So O and R, they don't match, would be minimum of this and this. First of all, minimum of this is 1. And then 1 plus 1 is 2. Now here O and O are matching, right? It means that there is no edit required. And we can just, if no edit is required, it means that we always remove these 2 characters. And if we remove these 2 characters, then we are left with hash and R and hash and H, which is this cell. Okay. So if O and O don't match, if O and O are matching here, we just take the number which is there from the left diagonal string. So here it's 1, we just pass it to 1 here, because there is no need to add anything of it. Similarly for S and O, we again go to the formula that S and O don't match. So it would minimum is 1 between 1, 2, and 3. So it would be 1 plus 1, 2. Again, let's go to the R and R match. In that case, the algorithm states that we just pass from the left diagonal up and pass the value here. O and R, O and R. So here this cell. So this would be the minimum I can see is 1. So 1 plus 1 is 2. Similarly, S and R minimum I find is 1 between these 3 cells. So it would be 2. Let's keep on going this. Minimum is 2 here. I will fill 3. O and S minimum of 2 will be 3. And S and S match. We just pass this here. It's 2. Again, R and E don't match. Minimum is 3. So it should be 4. O and E don't match. Minimum is 3. So it should be 4. S and E, they don't match. So it will be minimum of this. Minimum is 2. 2 plus 1, 3. So this is our final solution. So again, just to revise it, if the characters for a cell don't match, we take 1 plus minimum of the cell above it to the left diagonal or to the left. We take 1 plus minimum of all these three cells. Or if the characters match in this scenario, we just pass whatever is there from the left top into here. Now in the next video, the algorithm that we have derived here by using this 2D array, we will just solve it in Java. So stay tuned.